morning everyone, my name is Brendan Alexander and I will be teaching you guys how to solve this 7-point kinematics question. Okay? So before we begin, we must take a look at the question and identify the key points here, which is the acceleration formula given, and when time is equal to 0 seconds, the initial displacement is 4 meters and the initial velocity is 8 meters per second. Okay? So now the question is asking you to find the formula for the velocity in terms of t. So I want you guys to take a look at this diagram that I drew. When you go from the displacement to the velocity or from the velocity to the acceleration formulas, you need to differentiate with respect to time. But if you go the opposite direction from acceleration to velocity or from velocity to displacement, you need to integrate it instead. Okay? So for this question 3a, you need to integrate the acceleration formula, which is 2t plus 1 all to the power of negative 0.5. Okay? So using all of the integration rules that you have learned, when you have this type of expression, you need to take the coefficient of t, which is 2, and put it in the denominator. Then you should multiply it with the exponent added by 1. Okay? And then after that, you should copy the body of the equation, which is 2t plus 1, and then all to the power of the original exponent added by 1. And then you can just further simplify this expression until you get the simplest form, which is 2t plus 1 all to the power of 0.5. And don't forget the arbitrary constant c. And now all you need to do left is just to solve for the arbitrary constant. To do this, you need to use the information given in the question, which is when t is equal to 0, the velocity is 8. And now you just need to plug these values in, where v is 8 and t is 0. Eventually, your arbitrary constant will be equal to 7. Okay? There you go. You found your complete formula. Now your answer should be 2t plus 1 all to the power of 0.5 added by 7 meters per second. Don't forget the units. Next, for question 3b, you apply the same concept here, but instead of finding velocity, you're finding the displacement formula. Now, if you remember the diagram that we drew before, the displacement is one step down from the velocity. So all you need to do is just integrate your velocity formula to find a displacement formula. Okay? And then after that, you do the exact same process as before. First, find the coefficient of t, make it the denominator with 1 being the numerator, then multiply 2 by the exponent added by 1. Then multiply everything by the body of the expression 2t plus 1 to the power of the exponent added by 1. Now to integrate for 7, since 7 is constant, all you need to do is just multiply it by the variable t. Don't forget the arbitrary constant d. Now you need to simplify this expression before you can find d, okay? So if you simplify it, 0.5 plus 1 is 1.5, 1.5 times 2 is 3, so it should be 1 over 3 times 2t plus 1 all to the power of 1.5 added by 7t added by d. Now you need to solve for d, which is by using the information t is equal to 0 and the initial displacement is 4. So just plug those values in like you did before. And make sure you put the 4 on the left hand side of the equation because the 4 represents your displacement, okay, which is the subject of the formula you found. And then you can just keep on simplifying that equation. And because 2 times 0 plus 1 all to the power of 1.5 is equal to 1, you can just ignore it. And eventually, your arbitrary constant is 11 over 3. There you go, you found your answer. So your answer should be 1 over 3 times 2t plus 1 all to the power of 1.5 added by 7t added by 11 over 3. And don't forget the units, which is meters. Okay? There you go. You solved this 7-point question in just 5 minutes. So the important thing to remember here is all of the integration and differentiation rules, as well as the diagram that I drew before, to help you know when to integrate and when to differentiate. Okay, that's all for today. Goodbye.